Good morning, everybody, to the webinar about Civil 3D within the AEC collection. We are going to have a look at the interoperability between Civil 3D and specifically programs like Infraworks and Revit, and discuss it further in general. If you don't know what Civil 3D is, it is an AutoCAD vertical package, which is used for civil engineering design, specifically corridors, so road and rail corridors, bridges, and dams, and so on and so forth. The itinerary for today, we're going to have a look at Civil 3D and Infraworks, using Civil 3D to open an Infraworks model, and then that we have to pay attention between the Infraworks and Civil 3D coordinates, how we can get a Civil 3D model into Revit, how Infraworks can be used to federate models like Navisworks, and also that there are point clouds from Recap that we can use for generating surfaces. So first of all, there are two different file types that we can utilize when we are doing Civil 3D and Infraworks files. I always recommend that you have a look at the Autodesk help menu when you are interested in a program. In this case, we are looking at the Infraworks help program. You'll see that there's a list of detailed instructions as to how you can go about importing a Civil 3D model or an IMX file into your Infraworks model. And essentially, it's from a data source, and that you can then insert the data source, and from there you can manipulate it. Now, it isn't as straightforward as what you would think if it was just a Civil 3D model, because you would have to generate different scenarios and also delete some of the corridors if you are working with them. Just note that any of the information with regards to the exchange of data between Autodesk Civil 3D and Infraworks is available from within the help menu. As you can see, typically the flow diagram would be to, first of all, to create an Infraworks model, then to do the conceptual design, and then to close Infraworks, and then to open the Civil 3D model, and then do a detailed design in here. And then afterwards, closing Civil 3D, you can then open Infraworks and import the Civil 3D drawing again. Then you have to do what they call customized style rules. And then you can also later on re-import the Civil 3D drawing. Right, so there's an extra step where you have to manipulate how the Civil 3D will come through into Infraworks and then work it like that. So there's a nice flow diagram for you to follow as well. And then there's a lot of information with regards to exchanging the data with Civil 3D, what requirements are there. And there's quite a lot that's going on in there that you have to pay attention to. So the important thing to understand here is that the Civil 3D and Infraworks need to be on the same version for this process to work. So if you are working in Revit in Civil 3D 2022 or in Infraworks 2022, then you have to make sure that all of the software is on 2022. That also goes for Revit. So for the interoperability to work, especially with Infraworks, I would recommend that you always go with the same version of the software and make sure that all the same versions are applied throughout the entire supply chain. Then the Infraworks model and the Civil 3D models must share the same coordinate systems. That's critical. And you can set that within each. Only certain assemblies you know what a Civil 3D corridor is, it's made up of an assembly that is swept along the path, which is defined by a profile and an alignment, will be editable within the Infraworks model. Centerline assemblies, that's critical. And then it also helps to create a new proposal when you do that. Then in reverse, using Civil 3D to open an Infraworks model, you'll see that you can also open an IMX file. So you can do an export and import an IMX file, or you can open an Infraworks project directly. And again, the best source of information here will be from the help menu in Civil 3D. And then they talk about the reverse direction of going from Infraworks to Civil 3D. So these two help menus, I would suggest is the best way for you to understand this flow diagram, how to go from Infraworks to Civil 3D and then to interoperate between them. Note also that some local coordinates do not allow for this. So I recently came into contact with a coordinate system for Mauritius that was able to be defined for Civil 3D, but that does not allow for that to operate within Infraworks. They share the same database of coordinate systems, but if the coordinate system does not lend itself to that process, then you will be stuck. So to give you a practical example of how we might do this, here you can see that we've got an Infraworks model. Now, I've prepared this before the time so that we don't wait very long for the models to appear. Over here, for instance, you can see an area in Cape Town in Woodstock, and this is typically what the Infraworks model would look like if you just open it from scratch. It brings in information from GIS databases, and you've even got the further option if you want to go and bring in information from other data sources. There you can see the data source tool. And in that case, if you've got an ArcGIS connection, you can even bring in ArcGIS data from a GIS database that might be available within a municipality or within another company, or even on anywhere in the world. If there's an ArcGIS database, you can bring that in. On the data sources side, you can add a data source. And you can see that there are a lot of different types of files that you can bring in here. So 3D models, normal BWG, AutoCAD, Civil 3D drawings, which is the one, of course, that we would be interested in. The IMX file, which is an exchange format for civil databases. There's Autodesk Revit, City GML, DGN, IFC. IFC would be a popular one as well. That's the industry foundation class, often used within BIM, Land XML, point clouds, raster images, and so on and so forth. So there's an enormous amount of information that you would be able to bring in into your Infraworks container. So this is how we would start. In the background, what it does is it sets up a database, and that database is stored within your documents. Under your Autodesk Infraworks models in your documents folder, there you will find that you've got, for instance, your Autodesk 360 databases, and opening one of them, this one was on the 14th of the 11th. We are now on the 15th of 11th. That's the latest one that was opened. And there we can see there are different types of files. So there's an SQL Lite file right there, SQL LITE. And then within that, there is more information. So that would be the first step. You would use Infraworks, either from a model builder or for some other application from which you can then open up and save a part of the planet that you would be interested in. And you would also set the coordinate system for the model. You can see the model properties. The coordinate system that we specified for this is the UTM 8433 South coordinate system. So while it might not be as accurate as some of the South African coordinate systems, for instance, WSG 84 low 19, it does have the advantage that the X and the Y axes are aligned in a right-hand rectilinear sense. And in South Africa, I think Yemen and Vietnam are the three countries that I know of where they swap the X and the Y coordinate systems. Now, while you can set it up that it interoperates between Civil 3D and Infraworks in this manner, it does not operate well within Revit. So unless you need super accurate designs, I would recommend that you use one of the universal transfer Mercator coordinate systems. And you can see there are a lot that are available here. If you click on the globe there, you can see that you can also have a look at any specific country, typically, and then you can choose whichever one is applicable from a list that shows up. In our case, we've just gone with the 33 South Universal Mercator system. That is a point from which an XY coordinate system is chosen, and that is then what we use. And once the coordinate system is set, then that is the start of the process, because Infraworks and Civil 3D will therefore share the same coordinate system. All right. So like I said, just Skulk, I see you've joined us as well. We've got a new participant. We're just discussing to give you a quick recap, what we are busy with over here is we are looking at our Civil 3D as integrated into the AEC collection and how we can work with that. I've initially referred to the Infraworks help files that you can find online or otherwise from within your application itself. There's a nice flow diagram of how you would go about starting an Infraworks model and then to open it within Civil 3D, where you can also then start working in that and bring the Civil 3D model back into Infraworks and vice versa. So there's an interoperability here where you can use the two different software, and there's some very detailed information within the help files to help you with whatever it is that you're trying to bring into your Infraworks model. Similarly, within Civil 3D, you'll find that there is the reverse direction where we would go from Infraworks to Civil 3D. And again, there's some very detailed documentation here. So one of the things that we are just highlighting at the moment is that it's important to have a consistent coordinate system within a Infraworks model. This is an area within Woodstock in Cape Town. And because we are considering not only Infraworks and Civil 3D, but also Civil 3D and other applications, I'm just highlighting that when you do choose on your model properties to set a coordinate system, then it does help to signal a right-hand rectilinear coordinate system as opposed to one of the typical South African coordinate systems, which has X and Y swap. And the reason for that is not interoperability between Civil 3D and Infraworks, that between Civil 3D and some of the other packages, just so that the coordinate systems can share with each other. A lot of the workflows that we are talking about, I can't demonstrate in real time during this webinar because it does take time. So I'm working with some models that I've worked with in the past just to show you how the process would work. Now, the Infraworks model can also come with information that you can find from data sources. And those data sources can include one of many items, including any of these file types that you can see there. So not only AutoCAD, but also Civil 3D, IMX, Revit, IFC, Land XML, and other formats, as well as ArcGIS. So if you do have an ArcGIS data source, typically a municipality or a larger company would have information that is stored within the ArcGIS data sources, then you can go there to go and use that. It also includes point clouds. So point clouds are very often used within Infraworks as well as in Civil 3D. So all of them can operate together within Infraworks, and one of the advantages is that it is a package that can contain a lot of information, not only for planning and conceptual, but for visualization as well, and rendering and making movies and so on. So once you've generated this file, you'll find that it is stored within your documents folder under the Infraworks models. That's the default location where the SQL ITE file will be saved. Or alternatively, you can also export this Infraworks model into a file that Revit can, or that Infraworks can see. They call it an IMX file, and that you can output from within your Civil 3D, from within Infraworks and from within Civil 3D. So all of that is available. Then after that, you can actually open that file directly from within Civil 3D and then manipulate that. So the imagery, for instance, that you see in this Civil 3D file, I might show you a top view. The imagery that you see underneath the Civil 3D file is not from Infraworks. It is generated within Civil 3D by virtue of the coordinate system that we've chosen. I've just cropped the imagery to underlay the Civil 3D or the Infraworks topography that I brought in. I was originally just interested in the topography, and there you can see, for example, what the topography from Infraworks would look like. Now, it's quite rough. It's not very accurate. Of course, this is just the general sort of start of a project. But if you did have an ArcGIS database from which you can get much more accurate information, then that would be coming in. So that's the final graded surface. But it could also show up your alignments and the rest of the elements as well that you might have brought in. And you can see how they were brought in over here on the prospector on the left-hand side. So that you could start using to generate roads and so on from. So one of the things that I did over here is to say, well, this would act as a good start for a project. And I then just used some of the surfaces to generate two subsurfaces. Which when represented two positions from within which a building that I was busy designing would be generated. And these surfaces I could then use for a topography that I prepare for Revit or sharing into Revit. So there's an example of, as a first pass approximation for a Revit project, I used the data that's available within Infraworks to bring into Civil 3D from where I can do terraforming and prepare a basis for my buildings. Now, you can imagine this process would be a lot more detailed in reality because you will also model the infrastructure, and together with Civil 3D and Revit, then you can get a very accurate representation of what is going on within that building. Critically, you will notice that the coordinate system on this file, when we edit the drawing settings within the settings, is set to the same coordinate system. And there you can see that we are using the universal transverse Mercator with 33 south. So we've used exactly the same coordinate system, and that is why these two platforms can talk to each other. That's really what it's all about. From here, it's then possible within the miscellaneous utilities, which is now in Civil 3D 2022 automatically installed, but is also available within 2021 if you download and install it. There's a tool over here from which you can export a coordinate system, which you can also bring into Revit. It's interesting. There's the shared reference point that you can bring through. And essentially they require a point as well as a north direction. And that must also exist within Revit. So this Autodesk shared reference tool is within the subscription extension manager. And if you run it, then you can export your shared reference point to Revit when you execute it. And you'll see that it asks for a point and a direction that it will ask you to specify. And in Revit, you can then reverse the process and set your coordinate system correctly in Revit. After that, you'll find that your surfaces can be exported. Once you've got the same coordinate system within Revit and within Civil 3D, and that would be a shared coordinate system within Revit, that would be what the BIM manager would set up. You can then use the collaborate tools from where you can publish surfaces. And what this does is it picks up that you've got your surfaces that are here individually shown. All of them are ticked by default. But in my case, for instance, I would have the Z1FG and Z2FG surfaces ticked. And those one may then export individually into the cloud. So I did research this. You'll see that one of the requirements for publishing a surface is that you have Autodesk docs. That is the least amount of software that you would require. And you'll see that in your AEC collection, that is in fact part of the AEC collection. You get an Autodesk docs description. So when you get an AEC, why is this defaulting to AutoCAD now? There we go. When you do get an AEC license, you will be also given a docs license. And from docs, you can export that, or from Civil 3D, you can export that model into docs from where you can read it within Revit. So this limited docs license that you get with Civil 3D, with the AEC collection, that will allow you to publish your Civil 3D surfaces. So you wouldn't have to buy extra software if your only purpose of using docs was to export Civil 3D surfaces. From there on, it works through into Revit. Now, in my case, my computer won't be able to handle that all that easily, but let's see if we can find that on the internet. So here you can see the same information within the cloud where I've uploaded that. This is a drawing file, which is what the surface itself looks like when you publish it. So this would be an example of one of those surfaces, and having a look at our, I think it might be one of the structural files. Okay, so here's an example of one of those surfaces that was shared into the cloud. The file itself resides in the cloud when you publish it. So in this case, I would have published it to the shared documentation. So there you can see the .shared.bwg, .shared.bwg. That is the published surface. There's Z1. And all that is, it's from the Civil 3D surface. It is an export that looks like the follows. Here you can see the surface that was brought out. I've unfortunately included the other surfaces grading. So that would be a typical grading preparation for a building, which was then integrated into a surface. That is the surface. And this is the published surface that comes directly from Civil 3D and which you can link directly into Revit, provided that you've shared the coordinate system correctly. And then you will end up with this situation, for instance, where you've got, again, the structural model that has got the topography that is linked into it. So that's really the idea behind being able to work between Infraworks, Civil 3D, and Revit. You can do the same thing with point clouds, like I mentioned, and that is also something that we use quite often today. Okay, so just be careful with your coordinate system so that you can also take the workflow further into Revit. Some of the coordinate systems don't allow for interoperability between Infraworks and Civil 3D, especially very specialized ones. I know it is possible with some African coordinate systems to interoperate between Infraworks and Civil 3D. But if the X and the Y directions are flipped, then it does not extend to a Revit workflow. So we've already demonstrated that we can set the coordinate systems for both the Infraworks and the Civil 3D models. Then other items of interest in Civil 3D. So we've had a look at the surface that can be published. The other information is not available directly as a published link. Again, there's great information on the help files about how to import items into Revit that I would recommend you have a look at. And specifically, you'll see that there are different cases that are discussed. For instance, a Civil 3D drawing without pipe networks or corridors can be exported using the export AutoCAD command. You can type that into the command line to execute. And this will save a copy of the drawing with exploded civil objects. This is not always ideal, especially with surfaces, but you can also extrude surfaces within Civil 3D and generate topography from those surfaces quite easily within Revit. Then we've got Civil 3 drawings with corridors. Now, this is a much more detailed explanation. And again, the best would be to follow the instructions within the help files. You'll see how solids are extracted from corridors themselves. And then after all of that is done and a specific region within the corridor is chosen, then you can write that out and once again link that as extracted solids into your Revit file. So it comes down to being AutoCAD files in which the Civil 3D geometry has been not exploded, but extracted as solids, and which are then brought into Revit. So some of the items that would play a role here, for instance, is you'll know if you use Civil 3D that your alignments and your corridors are essentially differential sectors along the alignment which are swept. So if you go around curves, for instance, you'll find that there are straight lines around these curves. And if you want to have a really, really good visual representation, then you might decide to generate a lot of stations to interpolate between. That'll be a lot heavier on your computer, but then it will look better within Revit. So we're not always interested in a large portion of a corridor. We might just want to have the region of the corridor that is situated around the building, so we can get an accurate depiction of the curves and the road curvature and so forth, and then we just choose a specific region of the corridor so that we can bring that through in very much large detail. Again, a process to be managed and also based on the hardware that you've got and the ability of the hardware to manage the models. That's with regards to corridors. And then with piping and pipe networks, there are two ways that you can do that. There's a convert to solids command, and alternatively, you can also explode the items twice. And then if the solids don't display as desired, then you can use the mass element tool, or the mass element command rather, to convert the 3D solids to one or more multiple mass elements. So any of those will do. It is recommended that you isolate the objects within Civil 3D and write them out as a block. That's what the W block command is about. And then you can import that once again into a Revit section. So the idea behind all of these, so except for the topography, is that you will bring it out as solid AutoCAD objects and bring the solid AutoCAD objects into Revit. And then lastly, there is for those with the inclination and the aptitude, the option to use advanced workflows between Civil 3D and Revit using Dynamo, which is also now integrated into Civil 3D. We won't go into that much except to show that to you. And you'll see that there is a lot of information here that would be relevant. So that's once you know how to use your Dynamo within the projects, then you can have a look at the Python integration between Revit and Autodesk Civil 3D. And there are some components, adaptive components, that would allow you to generate surfaces and other elements based on the Civil 3D file directly. So you'd run the script, and the script would then generate for you within the other application, in this case, Revit. Then Infraworks can also be used to federate models, very much like Navisworks. Here you can see an example of some topography. There might be some point clouds. There's some Revit models and Civil 3D elements, and everything together being brought into Infraworks, from where you can have some or other elements that are displayed. Now, like I mentioned earlier, it's not as straightforward as just loading something in. You also have to configure the files correctly. I tried very shortly before I started the webinar and was unsuccessful. However, I'd like to show you the process in which this is done, and theoretically, which would bring the other elements in. They do recommend to start a new proposal and to delete elements, for instance, like the roads, because they will be duplicated. So if you did have a road here, you would start a new proposal and call that proposal something that you would like. Here you can add a new proposal. And then you would go about deleting the elements that you did not want to have duplicated. So if that was an alignment or a corridor originally, you would delete that, and you would carry on doing that, and then rather import the roads that you have designed within Civil 3D. Right? So you can design roads or typical roads within Infraworks as well. And then after that, you would resort to bringing in those files from a data source. Click on the data source connection, you can see your data sources are on there. And you would be able to bring in then your Civil 3D drawing. So they do say to close the Civil 3D drawing. I don't think there's anything else within the Civil 3D platform in the time that we've got that I'd like to demonstrate. I'm just going to save this AutoCAD Civil 3D file and close it. And so that corresponds to the workflow originally, which we saw within the Infraworks workflow, is that they close Infraworks and they close Civil 3D when they bring them into each other. So do not have them running at the same time. It often does not result in a successful translation of the files might generate an error, and you might think you've done something wrong, but you probably didn't. It's just that they're open at the same time. And once you've got these proposals open, then you can go about bringing in a data source. And that would be something like saying you'd like to import a Civil 3D drawing, and you would then browse to that drawing, which in this case would be on my C drive within my cloud. And you can see the cloud storage, which is synchronized to my C drive. And within this demonstration project, we will find the Civil 3D file, which we are working on. Yes, I think it will be this one. And then once we open that, it will give us the different categories that we can bring in. I see we're getting close to the end of the session. So these last two demonstrations will conclude the webinar. But you would then connect that to the data source and bring that back into Infraworks. And if you had constructed roads or corridors, that will be available for you because it would not be duplicated. And you will see in a moment when it brings that in. The same process is used for the Revit files. There you can see the different elements that they would bring in. In this case, we don't have any corridors to bring in, but there are surfaces. And then there's an additional step in here, which I have not yet perfected, where we should give styles to the elements. So your customized style settings as well. That would be an extra thing for you to do, where you can go and have a look at your corridors and see how you can then set up these styles so that they all look better. That then brings in the surfaces. There you can see that you've got them, they've come in, right? And they are configured because of the coordinate systems being similar or exactly the same within Infraworks and Civil 3D. There's the geolocation. You can see that it is the same using UTM 8433 South. And then you would also be able to bring in the Revit files. There's a Revit file, for instance. I did not get this to work this morning, but there it is. There's our Revit file that we might want to bring in. This does, you should have at least a PIM docs license to be able to do this. So that would be your, if you were working on the cloud, then you'd need the PIM docs. If it was on your hard drive, then you wouldn't. You just load it from your hard drive without having any sort of license to a cloud service. And that will then bring that in. Because I'm working on the cloud with this model, it will then upload that file into Infraworks and process that from here. And there you can see it's busy processing that. After you've brought it in, it does not recognize the coordinate system as such. You'll have to configure the file to appear in the correct orientation. after which you will end up with a model looking pretty much like this one over there. And then, I don't know, in the few minutes that we've got left, if you guys have got any questions that I might field at the moment, Gary or Skulk.
Nothing from my side, thank you.
Nothing from your side, Skulk. Gregari? Sure if he's there. In any case, if you guys do need further information with regards to Civil 3D and ways to go about using the AEC collection in your company, you're welcome to contact us at Micrographics. We've got offices in Johannesburg, Cape Town, Port Elizabeth, and Durban. And if that does not fall within the area in which you're operating, we can always assist you online as well. Thank you very much for attending. I hope that you've at least, yes, Rugare. No, we don't do, we're not specialists within bridge design. However, we might be able to put you into touch with somebody, say, for argument's sake, from Procon. They might have some specialities within there. We've got a very close relationship with Procon. But I would recommend that you have a look at Autodesk University. I don't know if you've ever had a look at Autodesk University. And they've got a brilliant course on bridge design in there, which is not a full-blown course, but it is a short course. And what you'll find also within bridge design is that there's an workflow between Autodesk Inventor and Civil 3D bridge design. So you'll find quite often that the bridge design will work between Infraworks and Inventor and Revit. So Revit is usually used to do rebar. So while the bridges are designed within Civil 3D, but then the rebar will be done within Revit typically. But the Inventor workflow is great because there your supports and your pylons can be designed within Inventor. The only pity about that is, unlike the old building design premiums that we got before the collections, Inventor is now no longer part of the AEC collection, and so you'll find that Inventor is no longer included. So it will be an extra license that you would have to purchase if you were to use the Inventor license as part of your design. So when you do look at these presentations or so on, then we can just take that into account, that you might need yet another license over and above what you've already got. But it will be my pleasure to have one of my sales guys get in touch with you. I don't know if I've got your email address. If you are willing to, what I'll do is, if you want, I can just type my email address in the chat box quickly. And then if you just want to send me an email, so I'm paul@mgfx.co.za. And if you send me an email, then I'll put you into touch and we'll try and find somebody that is a specialist in bridge design for you, which I'm not. So I'd rather tell you what I'm not. You know, I'm not going to fake anything. But I know that we're in contact with some great guys in Procon as well, which have done a lot of this type of work, and they might be able to assist you with that. So I would just be able to put you in touch with the correct person. Have you got my email address? Okay. Yes, so all of the Autodesk products, except in the entertainment and media industry. So we don't, although we do sell 3ds Max and so forth, our support doesn't cover things like making Hollywood movies. But anything that's within the manufacturing sphere or the architectural engineering and construction sphere, we cover. So we support, for instance, some motor manufacturers on the mechanical side, and a lot of manufacturing companies. That, again, it's not something that I personally support because I'm on the architectural engineering and construction side. But on the manufacturing side, we do have extensive resources also, and we do sell the software that's related to that. But even if you had technical queries regarding that, if you wanted to buy Inventor, yes, we can sell you Inventor as well. So anything Autodesk, and there are other software as well. If you go to our main website, it's micrographics.co.za, mgfx.co.za, micrographics.xa. We also see that we sell Lumion, which is visualization. But under the software, you'll see that we do the Autodesk collections and other, and then some of the other information that you can see there as well. So not only Autodesk, but also some of the other platforms that are available. And then we also do server installation, there's hardware, there's training, everything that's got to do with our company you will find on this main website, mgfx.co.za. But yes, so a lot of software that we do, as well as hardware and IT. We can also program, or we do also program specialized applications within the industry. If that is something that you require, then we've got programming resources in Port Elizabeth that can accommodate you with that. And we'll be able to provide you with a quote for whatever services you're needing. If I might ask, in what region of the country are you? If I might ask, in which region of the country are you? In Johannesburg, all right. So we've got an office up there. So I'll know who to put you in touch with on the sales side, and they will be liaising with you with regards to having somebody contact you about bridge design. That would be our pleasure. All right. Thank you very much, guys, for attending. I hope you have a wonderful day further, and stay safe during COVID. And thank you very much once again.
Thank you.